Hi all. Today we are going to be talking about trigonometry. In our last session, we talked about basic trigonometric functions and how those functions can be used to determine unknown values in a right-angled triangle. In this video, we will talk about how we can use these trigonometric functions to solve a right-angled triangle. So what do we mean when we say we have to solve a right-angled triangle? A right-angled triangle has three sides: perpendicular, base, hypotenuse. It also has three angles. One of the angles is 90 degree and that angle is known. The other two angles could have different values. The sum of the three angles in a triangle is always going to be 180 degree. Just remember that this will come in handy. And we know there are three trigonometric functions for a right angle triangle: sine, cosine, and tangent. And depending upon what is known and what is unknown, we will select the trigonometric function. So let's look at a problem. In this right angle triangle, we know that the perpendicular is 30 meters and one of the angle is 30 degrees. Let's say we have to find the base of this triangle. How would we go about doing that? First, we will have a look at what is known and what is unknown. So the known values are perpendicular, which is 30 meters in length, and the angle, which is 30 degrees. And the unknowns are base, which we have to calculate, hypotenuse, and angle number 2. Then we will look at the trigonometric functions and see which trigonometric function has the knowns and unknowns that we need to calculate. So we first look at sine function. Sine function has perpendicular and hypotenuse. So we know that perpendicular is known, but we do not want to calculate hypotenuse. And sine function does not have base in its equation. So we cannot use sine because it does not have base in it. Let's look at cosine function now. Cosine function is base over hypotenuse. It does not have perpendicular, which is a known value. So we cannot use cosine function also because we wanted a function that has perpendicular and base in it so that we can calculate base. Let's look at the tangent function. So a tangent function is perpendicular over base, and it has both the known value, which is perpendicular, and the unknown value, which is base. So we can use a tangent function to start solving the right angle triangle and start calculating the base. So tan theta is perpendicular over base. Tan 30 degree will be 30 divided by base. We solve it for base and we get 51.99, and then we include the unit of the length. So the base is 51.99 meter. So that's how you start solving a right angle triangle, by identifying what is known and what is unknown. And depending upon the knowns and unknowns, you select the trigonometric function that has the knowns and unknowns. And once you start solving a right angle triangle, then you move on to the next trigonometric function to solve rest of the triangle or to calculate other side and the other angle. So let's say we have to find hypotenuse of this same triangle. We can use a sine function now because we know that the perpendicular is 30 meter, angle is 30 degree, and we want to find hypotenuse. By using the sine function, we get the hypotenuse value of 60. We use the unit with 60 and we get 60 meters. So the hypotenuse is 60 meter in length. There's another way of finding the hypotenuse because this is a right angle triangle. We can use Pythagoras theorem. Our Pythagoras theorem says that square of hypotenuse is equal to square of perpendicular plus square of base. And we know that the perpendicular is 30 meters and the base we have calculated in the previous steps, which is 51.99. We use both of these values in the equation we get 30 square plus 51.99 square, which is equal to 900 plus 2702.96, and then we get hypotenuse square equals to 3602.96. We take a square root of that number and we get 60.02. So the length of hypotenuse is approximately 60 meters. So there are multiple ways of solving a right angled triangle. We can either use the trigonometric functions, and we can also use Pythagoras theorem depending upon what is known and what is unknown. Now let's try to solve the second angle of this right angled triangle. We know that in a triangle, sum of all three angles is equal to 180 degree. And we know that one of the angles in a right angled triangle is always 90 degree. And the first angle was given as 30 degree. What we can do is we can subtract 90 and 30 from 180, and this will give us 60 degree. So the value of second angle is 60 degree. So now let's see what is known in this triangle. We know that length of perpendicular is 30 meter, that was given to us. We know that length of base is 51.99 meter, which is what we have calculated. We know that one of the angle was 30 degree. We know that it is a right angle triangle, so one of the other angles will be 90 degree. We have calculated the length of hypotenuse, which is 60.02 meter. And we have also calculated the second angle, which is 60 degree. So now in this right angle triangle, we know all the values. So when we know all the values in a right angle triangle, we say that we have solved that right angle triangle. All three angles are known. Length of all three sides are known. So this is a solved right angle triangle. Hope you have found this session useful and have a great day. Bye.